Hello. How can you even tell? I just assume it's working.
Oh yeah, so you don't need to write. So are those the only two questions? We're learning the cross product today. No, not even. Yeah, well, yeah. Whoa. Whoa. Okay, only two questions then. 5. Oh, you guys, come on. You just did that on the quiz. Number 5. This is like the quiz problem today. Okay. Didn't I do an example yesterday too? You guys are so funny. Funny, strange, or funny, haha? Yeah, strange is correct. Find the measurement of angle A. It's the same as today's quiz. What two vectors form angle A? Vectors AB and AC. Anytime it tells you to find the measurement of an angle, what are you going to do? Dot product, right? So componentize vector AB. So if you go head minus tail, is that 0, 3, 4? Did I do that correctly? And then AC, head minus tail. 2, 1, -2. So to find the cosine of the angle formed by the two vectors, you compute the dot product, which is 0 plus 3 minus 8, all over the length of this vector, which is the square root, that's 5. And then the length of this vector is 3. Ooh, comes out nice. So that's -5/15, which is -1/3. So the angle is cosine inverse -1/3. You can just leave your answer like that, yeah? Or you can punch it in. What does that negative mean? The angle is obtuse. Okay, B. Find the area of this triangle now. Well, if you know two sides and the included angle, what's the fastest way to compute the area? 1/2 AB sine C, right? Or have we forgotten that? Okay, look, the length of vector AB, we already found it, is 5. The length of vector AC, we already found it, is 3. And this angle is cosine inverse -1/3. So therefore, the area of this triangle is 1/2 AB sine C. Now, you don't need a calculator. Did you guys use calculator for this? I didn't use anything because I didn't even do it this part. How do you find the sine of cosine inverse -1/3? You draw the triangle. What quadrant do I draw this triangle in?
1.
How can it be 1 when the argument
Oh,
is
wait,
negative?
negative. Oh.
Second quadrant or fourth quadrant? Second, because the range of cosine inverse is 0 to pi. We still gotta know that. Oh, you wait till next chapter. You gotta know all your trig identities, your values, and all the base graphs. And even some not base graphs. Woo! Okay, so second quadrant, I like to do this. And cosine is what? Adjacent over hypotenuse. So using the Pythagorean theorem, this is gonna be 2√2, correct? Because 1 plus 8 equals 9. You guys gotta be, when you go to calculus, you gotta be able to fill in right triangles very quickly. If you know 2 out of the 3 sides, you gotta come up with the third one. So, what is the sine of this angle that I just drew? SOHCAHTOA. SOHCAHTOA. Opposite over hypotenuse. So, this is equal to 2√2/3. Let the canceling begin! 3 cancels 3, half cancels 2. So all you're left with is 5√2. That's the area of the triangle. 1/2 AB sine C. No calculator. I almost put this problem on today's quiz, but then I figured out it's not like we didn't have one like the homework yet. Because if you know the sine of the angle, you can figure out all the other ratios just by drawing the triangle, right? And then number 8. You sure that's the only question? Everybody could do 6 and 7 and stuff like that. Because you see number 6, doesn't this bring back memories of conic sections? Yes, you're gonna have the same problems again, except it's 3-dimensional now. I'm going to describe a set of points. What's the set of points in space that are twice as far from this point as from this plane? This is just the beginning. Number 6 is the appetizer. Okay, good choice. I suppose. Here we have 2 points in space. 0, 0, 0, and B is 2, 4, 6. Write the equation of the set of points in the space. How do you know it's in space? Because it says x, y, z. If it was only in the Cartesian plane, it would just say f, x, and y, right? Oh, I can give you 4 dimensions then. The x, y, z, w. No, it's easy. You guys, what does equidistant mean? The distances are equal. Look, I didn't even make it like twice as far from one as from the other. It's just equidistant. We'll put, because some of you still put the 2 on the wrong side every time we go twice as far, right? How do you find the distance from here to here? Distance formula. So x minus 0 squared plus y minus 0 squared plus z minus 0 squared equals, how do you find this distance? You use the distance formula. X minus 2 squared plus y minus 4 squared plus z minus 6 squared. That's the answer. All you gotta do is simplify it now. Do you want me to do it? Look, you just square both sides. Can you see that x squareds cancel out, the y squareds cancel out, and the z squareds cancel out? Now let me just write the answer. X plus 2y plus 3z equal 14. What is that? That's a plane. How come it's a plane? Well, if you just think about it, it's a plane. Okay, in 2 dimensions, what's the set of points that are equidistant from 2 points in a plane? A line, that's the perpendicular bisector, right? But in space, what's the set of points that are equidistant from these 2 points? It's going to be a plane. That's the perpendicular bisector of that segment. See, it's a plane. This plane is the perpendicular bisector. It's equidistant. Every point on this plane is the same distance from these 2 points. That's today's lesson, by the way. We're going to write equations of planes. Just like in Algebra 1, when you first learned to graph, what's the first thing you learn? Write equation of line, right? But in 3 dimensions, it's a plane. Plane is the basic graph. Oh my goodness. Okay, number 7. Okay, if you don't know what to do, like I told you yesterday, componentize and just do what it says. 3, 5, 2, B, 6, 6, 4, and then here's the point P, it's Z. PA dot AB equals 0. Okay, before we even do anything, let's try to figure out what this graph's going to be. If the dot product of 2 vectors is 0, what does that mean? They're perpendicular, right? So A and B are 2 fixed points, right? These are fixed points. Where can I put point P so that vector PA and AB, so here's AB, are perpendicular? Where would point P go? Where can I put point P so that vector PA and AB will be perpendicular? Well, you can put it here, you can put it here, right? Where else? Could be anywhere on this plane, right? Yeah, so what you're doing is writing an equation of a plane, but you just don't realize it. So, let's just pretend we don't know that though. Just do what it says. Okay, so what we're going to do is we're going to componentize vector PA and AB. Okay, componentize PA. 3 minus x, go head minus tail. 5 minus y, 2 minus z. See, when you do it this way, there's no thinking involved. What about AB? 3, 1, 2. Just make sure you go head minus tail. And then the dot product of these 2 vectors is equal to 0. That's how you set up the problem. So how do you find the dot product of vectors? You multiply the x components. You multiply I'll put the 1 there for your viewing pleasure. You multiply the y components, and you multiply the z components, and you make that equal to 0 because this is your answer. And can you see that it's going to be a plane? Because x, y, and z are all to the first power. That's a plane. Okay, you simplify. And then number 8. X minus 1 squared. This problem is just easier than you think it is, that's why. Maybe some of you are overthinking. Write the equation of the set of points in the xy plane that are also on this sphere. Okay, you guys know this is a sphere right after doing the homework. It's kind of like a circle, yeah? The center of the sphere is 1, 2, 3, and the radius is 5. And the hypersphere would be the same thing, yeah? So basically, this problem is asking you, where does this sphere intersect the xy plane? But if you're in the xy plane, just think about it, xy plane. If you are here in the xy plane on the floor, what can you say about the z coordinate? It's 0. So how do you, in fact, that z equals 0, that's the equation of the xy plane. Because the z coordinate is always 0. So how do you think I'm going to figure out where this and this intersect? You just plug in 0 for z. That's it. That's the answer. Except you take the 9 and move it on that side. And what is that? What is the remaining graph? It's a circle in the xy plane. Well, if you think about it, if you have a sphere and it intersects a plane, isn't the intersection a circle? And that's what you find. This is what you get is the intersection of the two, which is a circle in the xy plane. Which brings me to this. Okay, okay, in 3 dimensions, let's see how good you are. Did you guys think about 3 dimensions? Okay, in 2 dimensions, what is that a graph of? It's a circle of radius 1, center at the origin. But in 3 dimensions, what's the graph of that?
Cylinder.
Very good. It's a cylinder. Some of you are thinking sphere? No, sphere, you just have z squared. X squared plus y squared plus z squared equals 1. That's a sphere. This is a cylinder. How come? Because there's no z in it. That means z can be anything. But x squared plus y squared equals 1. What is the graph of x squared plus y squared equal 1? It's a circle of radius 1, but that's when z is 0. What about when z is 1? You could have the same circle. What about when z is 2? You have the same circle. So cylinder. Infinitely long toilet paper roll. That's what it is. No, because I'm going to, you know the test. There's going to be a list of equations. You got to tell me what the graph is. Cylinder, hyperbolic paraboloid. Right now that you know what it is, right? Oh, by the way, I was fiddling around with the pocket cast thing. You know when you graph, well, 2 or 3 dimensional stuff, you don't have to type in z equal. You can just type in the equation because it's assumed z equals already. You know what I'm talking about? Yes. So when you do a 3D plot, you just punch in x squared minus y squared. Or I guess you got to go x raised to the 2nd power minus y raised to the 2nd. You don't have to go z equals. And same thing in 2 dimensions. So you don't have to type in y equal. You can just type in x squared minus x. And the thing will just graph the parabola. And if you want to graph polar, you just tell it graph like 3 sine of 5 theta. You don't have to type r equal. Because if you use theta, it assumes the r part already. Yeah.
How come you can't just type xy? Like instead of the count?
Because you got to type x times y.
Oh.
Yeah, you have to put the, so actually you might have to put the times here, but I don't think you need to because 5 is a constant. You know why? X and y are variables, that's why, and then what if, yeah, I don't know. Just do it. Okay, how much time do we have? Oh my goodness, we're in trouble. Luckily tonight's homework is tomorrow. Tomorrow you better bring your right hand because we're going to learn the right hand rule. Now I understand you guys in physics already learned it? Right hand rule? It doesn't matter. I'm going to teach you like you don't know anything anyway, right? So today we're going to write equations of planes. Now, what is the equation of a plane? I kind of already told you already. Ax plus by plus cz plus d equals 0. Anytime x, y, and z are all to the first power, this is a plane, boss. Okay? Now, in 2 dimensions, you have a line, right? What are the 2 things you need to write an equation of a line? You need a slope and a point, right? Then you can write the equation of a line. In 3 dimensions, if you want to write the equation of a plane, Here, I'll try. This is the way to kind of draw it in three dimensions. A plane extends forever. You need a point, of course, that it passes through, and then you need. But there's no such thing as slope in three dimensions, right? It's a two-dimensional concept. So what is the three-dimensional counterpart of slope? Anybody?
Tilt.
Okay, at least tilt is a good word, kind, but not really. Okay. It's called gradient. It's the perpendicular vector. And we call that, usually we call the perpendicular vector n. You know why? You guys in physics, come on. Normal. Normal means perpendicular, right? The normal force. Okay, so here we go. To write an equation of a plane, you need a perpendicular vector, which is like slope, and a point. So let me give you an example. Let's say that write the equation of a plane whose perpendicular vector is 2, 3, 4, and it passes through the point 3, 2, 1. Do not get these two confused now. When you have this thing that's a vector, this is a point, yeah? Watch how easy this is. If this vector is perpendicular to the plane, the equation of the plane then is 2x plus 3y plus 4z plus v equals 0. Where did the 2, 3, 4 come from? Are you crazy? Look, it's a perpendicular vector. The x component is the x coefficient. How do I figure out what this constant is here? You plug in the point. So if I plug in 3 for x, and 2 for y, and 1 for z, we can figure out the value of d. So you get 6 plus 4 plus d equals 0. Therefore, d is negative 16. Therefore, the equation of this plane is 2x plus 3y plus 4z minus 16 equals 0. It's that simple, people. So you guys understand that? To write an equation, that's all you're doing tonight. To write an equation of a plane, you need a perpendicular vector and a point. Now, on some of the problems on tonight's homework, I actually tell you what the perpendicular vector is. But in other problems, you've got to find this perpendicular vector. I think that's all I have to say, yeah? Or do I have to say some more? So all tonight's homework is, you're writing equations of the plane. No exotic graphs, just planes. Okay, so here's one problem in tonight's homework. I don't know why students get confused with this, but you do. Let's say you have a box here. Oh, missed. Okay, so let's say the dimensions of this box are 6 by 5 by 4. So in other words, this point there is 6, 5, 4, right? What's the equation of this plane that contains the top of the box? What's the equation of that plane? Z equals 4. That's right. Because every y coordinate there is z, right? It doesn't matter what x and y are. The z coordinate is always 4. You're always 4 units above the xy plane. It's just like this in 2 dimensions. What's the equation of this line if this is the point 3, 4? How can that be? Negative 2. What's the equation of that line? Are you joking? X equals 3. It's a vertical line because every single point on this line, the x coordinate is 3. Same thing here. Every y coordinate is 4. It's the same thing. If you have difficulties in 3 dimensions, just think 2 dimensions. Okay, what's the equation of this thing there? Y equal 4, because all the y coordinates are 4, no matter what x and z are. It's 5. See the problem. Okay, I think you guys can get it. Yeah? So to write an equation of course, if it's like, see, like this, do I have to use point slope form when I write vertical and horizontal lines? No. So just like over here, if the planes are like parallel to one of the planes, you don't need to do the perpendicular vector thing, right? Okay, last thing. Did you guys think about 4 dimensions? Okay, now this is how we think of 4 dimensions. That's why before, flat land used to be required reading. in geometry, but I think I don't know when they stopped that. Anyway, flat land, there's these beings that live in 2 dimensions. Did we talk about this yesterday? Okay, women are lines. These are the women. These are the females. Men are polygons. So, like this. And the more sides you have, then the more noble you are. So everybody aspires to be a circle. Right? Because that's kind of like a polygon with an infinite number of sides. Yeah? So the more, so somebody like this would be like a governor. This would just be like an everyday citizen of Flatland. So the citizens of Flatland live in a plane. They're 2-dimensional. And this is how you think of 4 dimensions. Okay, you think of by analogy. Now, I am a 3-dimensional person. I come to their world. What if I'm standing right here? This is their universe now. They only can see and in what's in their plane, right? By the way, women are very dangerous because they can impale you. Because think about it. If you're a polygon and a woman is approaching you, you know, like straight on, how do you even see her? Doesn't it just look like a point? Right? That's why women, well, if you read the book, they have to make these sounds so that you know they're there. They have to emit sounds. Otherwise, you don't know. You can, okay, anyway, we only got 2 minutes left. Okay, now, I'm a 3-dimensional person. Can they see me right now? No, the only way they can see me is I have to enter their world, their universe, which is the plane. What about here? Can they hear me? Hello? Can they hear me? Yes, because the sound waves are going into that plane. Right? Hello. So they're looking around, but they don't see anybody. It's like magic. But if I want them to see me, what do I have to do? I have to enter their universe, their plane. So how do I do that? Yeah, so I put my body into their plane, right? So they can only see a cross-section of me, right? So I put my finger in, and all of a sudden, out of nowhere, you see that, right? A cross-section of my finger. Then I put it further in, then they see my wrist, right? So it's like, all of a sudden, there's nothing, and then there's a little circle, that was a big circle, and then I put my forearm in, right? It gets bigger. And I put my bicep in. And then I pull it out, and then it's gone again. So isn't that like magic? They can hear, but then they have these things that's changing. So what if a 4th-dimensional being visited our universe? What would happen? Yeah, we only can see a cross-section of them, but a cross-section of them would be 3-dimensional. So we could hear things, right? And then we don't see anything. And if they choose to, they can put part of their body in, and we would see a cross-section of it. And that's how you think of 4th dimension. And just imagine how, look, if you are a 3-dimensional person, you enter a 2-dimensional world, you could do this. Right? And then you could operate on them without even having to go in. Right? Because in 2 dimensions, their doctors have to cut a hole and do stuff. But if you're a 3-dimensional person, you can just do the surgery without even cutting them open. So if we could harness the 4th dimension, we could get a friend, and they could perform surgery on 3-dimensional beings without even opening up our bodies. No,